This is our second video in the series on solving trigonometric equations. If you didn't see me solve problems 1 through 4, you should go back and watch the previous video. As I go throughout this video, I'm going to be assuming that you know all of the facts on this trig table. If you haven't memorized these facts, pause the video, copy this down, and memorize it right now. Same goes for the basic trig identities. Write this, copy this chart down, and make sure that you can reproduce it within 1 minute. So for the rest of the video, I'm going to assume that you could reproduce both of those charts I just showed you. Okay, now looking at problem number 5, I see that we have secant and we have tangent. I do not like having two different types of trig function. So the first thing I'm going to do is do a little substitution. Let's see, tangent squared is on this chart. Okay, tangent squared is equal to secant squared minus 1. Looking at the blue right here. Tangent squared is secant squared minus 1. So I'm going to make that substitution. Be careful of the minus sign here when you do this. So I'm going to have secant squared minus 1. But I'm going to put it in parentheses to remind me to distribute that negative sign. So what I will have then is negative 2 secant theta plus 2. Alright, I just brought all of that down. But now as I distribute this minus sign, then I will have negative secant squared. Whoops, I forgot the theta. Boo. Alright, I will have negative secant squared theta plus 1, because negative times negative is a positive. Now I have all secant, so that's better. I see that I do have secant and secant squared, so this is the type of problem where I need to get 0 on one side and factor. So I'm going to go ahead and add secant squared theta to both sides. And I'm going to subtract 1 from both sides. So that's going to give me secant squared theta minus 2 secant theta plus 1, all right, combining like terms here, is equal to 0. All right, so this is probably factorable, so I'm going to go ahead and attempt to factor this. Secant squared can only factor as secant times secant. 1 is only going to factor as 1 times 1. Now the key to my method of factoring is inner plus outer must equal the middle. Inner, I have 1 secant theta. I'm multiplying these. Outer, I also have 1 secant theta. If I add these up, I need it to equal this middle term, negative 2 secant theta. That will happen if I allow both of these to be negative. That'll make negative 2. So if these are both negative, that means that these have to be both negative. And negative 1 times negative 1 is positive 1, so that works out. Okay, so let us set each of these factors equal to 0. Alright, so secant theta, oh, well they're both the same, so I'm not going to do it twice. So secant theta minus 1 equals 0. Whoops, not 10. That's all we have. Adding 1 to both sides, I have secant theta is equal to 1. Now secant is the reciprocal of cosine, so taking the reciprocal of both sides, I get cosine theta is equal to 1. Alright, the reciprocal of 1 is still 1. So the cosine of what angle is 1? Well, that's none of the ones on the chart for sure. This is a quadrantal angle. That means we're talking about the angles that are at the quadrants on the x and y axis. So right here I have the point 1 comma 0. This at the top is 0 comma 1. Over here on the left is negative 1 comma 0, and on the bottom is 0 comma negative 1. Cosine is an x value on the unit circle. So we are only looking at these numbers. So the cosine of what angle is 1? Well, we're talking about this guy right here. Alright, so we're talking about this. Alright, it said between 0 and, I'm looking back at the directions real quick. It says between 0 and 2 pi. Notice it's less than or equal to on the 0, but not on the 2 pi. So we are not allowed to go all the way to 2 pi. So I had to decide real quick whether to think of this, where am I? I had to decide whether to think of this as 0 or 2 pi. So I looked back, and we're supposed to call this 0. So there it is. Theta is equal to 0. That's the only answer. So the answer is C. On problem number 6, we have sine and cosine. I don't like that. I want one trig function throughout. So I'm going to do a substitution. I'm going to substitute sine squared for something, since the rest of the problem is all cosines. And looking at our trig identities, sine squared is equal to 1 minus cosine squared. So I'm going to make that substitution. Be very careful with your negative sign. As you do 1 minus cosine squared, you need to keep that negative sign out in front of your parentheses. Okay, right, sine squared, 1 minus cosine squared. Okay, so I need to distribute this negative sign throughout. So that's going to give me negative 1 plus cosine squared theta. Alright, that's that part. Now the rest of it, minus cosine theta is equal to negative cosine squared theta. Alright, I need to get 0 on one side, so let's add cosine squared to both sides. So that is going to give me 2 cosine squared theta minus cosine theta. And see this minus 1 over there? I'm just going to put it over here, is equal to 0. Now this is probably factorable. So let's attempt to factor it. 2 cosine squared will only factor as 2 cosine theta times cosine theta. 1, I'm ignoring the negative sign for now. 1 can only be 1 times 1. Now the key to my method is inner plus outer equals middle. The middle is like a negative 1 right here. So inner, I have 1 cosine theta. Outer, I'm talking about these two. I'm multiplying, so that will give me 2 cosine theta. Together, these have to equal the middle of negative 1 cosine theta. That will happen if I have a positive 1 and a negative 2. So that means this first one needs to be positive and the second one needs to be negative. That works out because positive 1 times negative 1 is negative 1. So that's great. So now I'm going to set each one of these factors equal to 0. So I have 2 cosine theta plus 1 equals 0. And I have cosine theta minus 1 equals 0. So over here, if I subtract 1 from both sides, I get 2 cosine theta equals negative 1. If I divide both sides by 2, I get cosine theta is equal to negative 1/2. Alright, let's follow through and solve this out. Let's find the reference angle. Cosine of what angle is 1/2? Ignore the negative sign for a second. Okay, boom, pi over 3. So the reference angle is pi over 3. Okay, so this is what you should be thinking in your brain. You should not have to draw this picture. So these are the 4 angles that have a reference angle of pi over 3. Cosine is an x value on the unit circle. So for that reason, cosine will be positive in these 2 quadrants and negative in these 2 quadrants. Well, for this angle, the cosine is negative. So that's why we are these 2 angles will be the solutions. And this is 2 pi over 3 and 4 pi over 3. So theta is equal to 2 pi over 3 and 4 pi over 3. Now, what about this other equation, cosine minus 1 equals 0? Adding 1 to both sides, we get cosine theta is equal to 1. So this is going to be a quadrantal angle. I can tell it's not on the chart. And I know that if I look at the quadrants, over here I have 1 comma 0, and up here 0 comma 1. On the left is negative 1 comma 0, and at the bottom is 0 comma negative 1. On the unit circle, cosine is an x value, so that's why I'm only going to be looking at these numbers. Now, the cosine of what angle is 1? Well, that's only going to be this guy right here. It's the only one. Which means 0. Right? This position right here is 0. So I'm just going to add 0 to the list. Alright, so there you go. 2 pi over 3, 4 pi over 3, and 0. So that's why the answer to number 6 is going to be A. For number 7, I like the fact that it's all tangent. That's a good thing. So I can just jump right in. Let's get 0 on one side. So I'm going to add tangent squared theta to both sides. Okay. No, add 2 tangent squared theta to both sides. That's what I meant to say. So combining these like terms here, that will give me tangent squared theta, which will go first. So I'll have tangent squared theta, and then plus 2 tangent theta plus 1 is equal to 0. Alright, this is probably factorable, so let's give that a try. Tangent squared can only factor as tangent times tangent. 1 will only factor as 1 times 1. Now the key is that inner plus outer must equal the middle. Inner, I have 1 tangent theta. Outer, multiplying these, I also have 1 tangent theta. Together, they have to equal the middle of 2 tangent theta. That will happen if I let both of these be positive, which means that both of these would be positive. And positive 1 times positive 1 is 1, so that works out great. So I've got to get these out of the way. So I need to set these factors equal to 0. They are the same, so I only really need to do one of them. So I will say tangent theta plus 1 equals 0. Subtracting 1 from both sides gives me tangent theta is equal to negative 1. So this is going to be a quadrantal. No, I lie. This is on the chart. Tangent of what angle is equal to, well, ignore the negative sign for a second, because let's find the reference angle. Tangent of what is 1? So remember, the tangent of pi over 4 is 1. So that tells us that the reference angle is pi over 4. Now, consider the chart, which you should be picturing this diagram in your head. Alright, this is a diagram of multiples of pi over 4. Okay, so all 4 of these angles have a reference angle of pi over 4. So if I take the tangent of any of them, I'm going to get either 1 or negative 1. Tangent is positive in these two quadrants and negative in these two quadrants. So in this case, the tangent of theta is equal to negative 1. So that means the solutions will be here and here. So that means theta could equal 3 pi over 4 or 7 pi over 4. And that's it. So that's why the answer to number 7 is A. Okay, let's just do one more problem on this video, and then we'll wrap it up and make another video. This only has one trig function in it, sine, so we can just jump straight in. I see actually two different ways I could do this problem. I think I'll do it both ways just for fun. So one thing I can do is this is the difference of two squares. Alright, 4 and 1 are both perfect squares, and this is the difference. So I think it would be interesting to use that fact. So we should be able to factor this right away. We would just do a, you know how when you do a squared minus b squared, the difference of two squares, it factors as a plus b times a minus b, right? So we're going to do that same thing. I'm going to do a plus b, a minus b. So that'll be 2 sine theta plus 1 times 2 sine theta minus 1. Alright, and then I can set each one of these factors equal to 0. So I will have 2 sine theta is equal to negative 1. Wait, I'm skipping a step. Alright, I will have 2 sine theta plus 1 equals 0. And I will have 2 sine theta minus 1 equals 0. So this is going to give me, so subtracting 1 from both sides and adding 1 to both sides, I will have 2 sine theta equals negative 1. And I will have 2 sine theta is equal to positive 1. Now dividing both sides by 2 will give me sine theta is equal to negative 1/2, and sine theta is equal to positive 1/2. Alright, notice that we have 1/2 in both cases. Just one is positive and one is negative. So the reference angle is going to be the same in both cases. So what is the reference angle going to be? Hopefully you're thinking pi over 6 right now. Okay, the sine of pi over 6 is 1/2. So that is the reference angle. Alright, so now picture the chart. Picture the diagram of pi over 6's. And I'm going to draw them all because some people need that, but really you should be able to do this in your head. Okay, you should be able to do this in your head just by picturing these two. In fact, maybe I'll draw these other ones, and then I'll erase them. Okay, can you see that right here I have a bunch of pi over 6's? Alright, I have all the multiples of pi over 6. And these four are the four angles that have a reference angle of pi over 6. Now, that's too much to picture in your head, but we don't need these lines. This you can picture easily in your head. You know that this is pi over 6. But what about this? Well, over here on the far left is pi, which is 6 pi over 6. Maybe I should write this down. So this is pi over 6. So you know that this is 5 pi over 6. And this is 6 pi over 6, so this is 7 pi over 6. See, I'm trying to show you how you can do this in your head. You know that on the far right, this would be 2 pi is the same thing as 12 pi over 6. So that makes this 11 pi over 6. Alright? So you should be able to hold this in your brain. Now, all four of these angles, if you take the sine of them, you're going to get either 1/2 or negative 1/2. Okay, so we want them all. We want all of these angles. Because we have positive 1/2 and negative 1/2, sine is going to be positive in, sine is a y value, so it's positive up here and negative down here. But because we have positive 1/2 and negative 1/2, we want all four. So all four of these will be the answer. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. That's why the answer is going to be B. Okay? Now, so I did this by factoring the difference of two squares. I told you that there was another way to do it. So I'm going to go back and do it the other way now. So what I could have done instead was I could have just started solving for theta. So I could just add 1 to both sides. So that would give me 4 sine squared theta is equal to 1. And then if I divide both sides by 4, that's going to give me sine squared theta is equal to 1/4. But then I would have to take the square root of both sides. Now be careful, because when you take the square root, you're going to have plus or minus. So that will give me sine theta equals. Now, the square root of 1/4, remember, you're just doing the square root of 1 and the square root of 4. So that's going to give me plus or minus 1/2. Okay, now, can you see that that's the same thing that we got when we factored it? Let me scoot over a little bit. Alright, this plus or minus 1/2 is the same thing that we had. So from there on, it would be the same, and you get the same answers. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.